All right, today we're going to build a bridge between two worlds you'd probably never think to connect: the concrete jungle of massive construction projects and the intricate microscopic world of human biology. And the blueprint that links them both is a really powerful idea.
So let me just ask you, what does building a skyscraper have in common with curing a disease? I know, it sounds like the beginning of a bad joke, but the answer is this incredibly elegant principle that solves one of the biggest problems facing any complex project you can imagine.
To really get the solution, first, we've got to wrap our heads around the problem they both share. And that problem is a fragmented reality. Think about it. In any huge, complex project, when teams work in their own little bubbles, in silos, you get chaos. It doesn't matter if it's architects with blueprints, doctors with patient data, or researchers with trial results. Pretty soon, everyone has their own version of the truth. And that leads to really costly errors, people doing the same work twice, and some seriously dangerous blind spots. It's a universal problem of information breakdown.
So, how in the world do you fight that kind of chaos? Well, you have to forge a single, undisputed source of truth. And the solution has a name: the Common Data Environment, or CDE for short. The best way to think of it is as a central digital vault where every piece of project information is collected, managed, and shared. Its entire purpose, its whole reason for being, is to make sure everyone, and I mean everyone, is working from the exact same playbook.
I love this analogy. A CDE basically acts like an entropy-to-order funnel. It takes all that messy, disconnected data, the stuff scattered across emails, different spreadsheets, and random files, and it channels it all into one single, structured, totally reliable resource. And this resource serves the project from day one all the way through its entire life.
Okay, so let's dig into this concept in the world where it was actually born: construction and engineering.
Right, so in construction, the CDE is the absolute heart of the project. It's what ensures that the architect in the office, the engineer doing calculations, and the contractor on the actual job site are all looking at the latest approved blueprint. This single source of truth just dramatically reduces mistakes and costly rework, and it automates all these complex review and approval workflows. And look, this isn't just some clever strategy a company came up with. No way. This is a rigorous global standard, ISO 19650, that actually sets the rules for how information has to be managed on a building project, from the very beginning to the very end.
And the information in this system, it isn't just dumped into a folder and forgotten. Oh no, it has a life of its own. It actually matures through a very specific, standardized life cycle. So the data moves through 4 key states. It starts as a work in progress, a draft. Then it gets shared for everybody to review and comment on. Once it's approved, it becomes published, which is the official version everyone works from. And finally, it gets archived as a permanent record. It's a simple, elegant process that makes sure everyone is using the right info at the right time. Okay, so we've seen how this brilliant system works for steel and concrete. Now for the big jump. It's time to build that bridge from blueprints to biology. And here it is. This is the big aha moment of this whole explainer. The exact same logic, the same architectural thinking that we use to manage the insane complexity of a skyscraper can be applied to the immense complexity of human health. The goal isn't just to build a structure anymore. It's to build a complete, living picture of a patient. When you look at it side by side like this, the parallels are just stunning. In construction, the asset is a building. In healthcare, it's a patient. Construction data comes from things like engineering files. Healthcare data comes from medical records, imaging, and genomics. But the ultimate goal, that's where it gets really powerful. It shifts from zero rework to something infinitely more important: zero preventable harm. It's the same exact philosophy, but now it's being applied to save lives. So, what does this CDE logic actually unlock in the world of medicine and research? Well, it's nothing short of a revolution. So in practice, a healthcare CDE pulls together every single piece of a person's medical history: their electronic health records, their lab results, their x-rays, even their genetic data, and it creates one single unified patient view. This gives doctors a complete history of that person over time, which allows for dramatically faster and way more accurate diagnoses. Now, the big challenge, of course, is that all these different data sources speak different languages, right? An MRI file isn't structured at all like a lab report. And that's where these industry standards for interoperability are so critical.
They basically act as universal translators, allowing all this different health data to communicate seamlessly. And the payoff in the real world is absolutely huge. This one approach is transforming healthcare across 6 fundamental pillars.
Just think about the impact here. This framework powers clinical decision support, where an AI can scan a patient's vitals and flag a risk for something like sepsis in real time. It's the engine behind precision medicine, where you can combine a patient's clinical history with their genomic data to tailor a cancer treatment just for them. It even transforms pharma and research by finding eligible patients for clinical trials in days, not months.
So, when you take a big step back from all the details, what have we really been talking about this whole time? We've been talking about the architecture of truth itself. You see, the common data environment isn't just a piece of software or some tech system. It's a philosophy. It's a deep commitment to creating a single source of truth. And honestly, it's the only way we can truly understand and improve our most complex systems, whether they're made of steel or whether they're made of human cells. And that really is the powerful central idea to take away from all this. Whether you're managing the construction of physical steel or decoding the unbelievable complexity of human biology, the CDE is the architecture of truth. Which leaves us with a pretty fascinating question to think about, doesn't it? If this one framework can so elegantly connect blueprints and biology, what is the next great frontier that's just waiting for its own single source of truth?